Good morning, dear students. In last class, we studied about the phase difference, and same phase, opposite phase. When two particles are vibrating in same phase or in opposite phase. In same phase, the phase difference is nothing but what? It is 2n pi, and the time difference is n t by 2. Okay, and another one is n into t is there. Then another one is that is path difference. The path difference is again it is n lambda. When the two particles, it means when two particles are vibrating opposite to each other, the phase difference become the odd integral multiple of pi. Here in same phase, even integral multiple of pi, that is 2n minus 1 or 2n plus 1 pi, and the path difference is nothing but it is 2n minus of half of that is lambda by 2, and another one is the time difference is 2n minus 1 or 2n plus 1 t by 2 is there. Half of the time period, half of the wavelength, and half of the total angle for one revolution, that become pi. Okay, now today will discuss about the simple harmonic motion. In previous class, it means in one class we discussed the harmonic oscillation and non-harmonic oscillation. Harmonic oscillations are nothing but what? There is the oscillation of a particle or a periodic motion of a particle which expressed in terms of a single harmonic function, that is one it may be sin theta or cos theta. Theta become omega t, it is in terms of the angular frequency as well as the time taken. Okay, this is called the harmonic oscillation. Non-harmonic oscillation is nothing but it does not express in terms of the single harmonic function. It is a combination of two or more than two harmonic functions, sin, cos, or the angle will change here. Okay, in this simple harmonic motion, it is nothing but a periodic motion. It is a special type of periodic motion in which the particle moves the two positions, to and fro position, or those are also called as back and forth. Okay, to and fro repeatedly about its main position. Then main position is nothing but what? When initially that particle at which place the particle is there. Okay, and the restoring force. The restoring force, it means what? The particle comes back due to some force. That force is called what? The restoring force. Whose magnitude of the force, okay, the magnitude of restoring force is directly proportional to the displacement of the particle from the mean position. What is the displacement of the particle from the mean position is very important part. Okay, it is nothing but what? The displacement of the particle from the mean position. But restoring force is nothing but it is towards. Here one sentence is there. The restoring force is always directed towards the mean position. Okay, it is always directed towards the mean position. It means what? The restoring force is towards the mean position. The displacement is from the mean position. It means these two are opposite. It means the negative sign will be happening. Okay. In this simple harmonic, I will explain this completely simple harmonic motion in two types. Okay, right here the two types of simple harmonic motion types. I will explain this completely. Types. First one is the linear simple harmonic motion. What it means? Linear simple harmonic motion. Linear means the particle displaced in a straight line, along a straight line. It means if the force is also along a straight line. Example for this one. It means the example is when there is a rigid support and there is a one table or something is there here kept. One mass is kept on this table whose mass quality is a m, which is connected to this rigid support with the help of a spring. There is a spring. Okay, when you apply the certain force here, if you pull this one, if you just pull like this, that is called the external force because applied by us. That is called the external force. When the external force is just removed, it means up here. If you apply like this, the displacement is also there. The displacement is up here. Okay. When the external force is just removed, it repeats its mean position. Call this is a mean position. It repeats its mean position and it covers the same displacement in the other side. Here also, it covers the same displacement. It is due to what? It is due to the restoring force. It is due to the restoring force. It means when the external force is just removed, that body under the action of that restoring force. This restoring force is always directed towards the restoring force, directed towards the mean position. It means what? When if the particle is at here, when just we remove this external force, it comes back. It comes back means what? Restoring force towards the mean position. And the displacement should be from the mean position. It means the restoring force is directly proportional to this displacement here. The displacement is directly proportional to the external force. Again, same here, the external force is equal and opposite to the restoring force because it is in opposite direction. Okay, the external force is equal and opposite to the restoring force. It means the external force is equal to the restoring force but in the opposite direction, so that it is a minus. Okay. Then the restoring force is opposite to the displacement of that. Again, it is the restoring force in this linear simple harmonic motion. The restoring force is directly proportional to the displacement of the particle. That particle, the displacement of the particle should be negative because the restoring force is towards the mean position, but the displacement of the particle is from the mean position. Okay. This is the very important point in this linear simple harmonic motion. What is meant by linear simple harmonic motion? It is nothing but an oscillatory or a periodic motion of the particle which oscillates. It is a motion of the particle which oscillates to and fro from its mean position. From its mean position from here. Then it is moving along a straight line. It means it should be moving in a straight line. Okay, its definition is here: linear simple harmonic motion. The oscillation or a motion of a particle. The motion of a particle which oscillates to and fro about its fixed point or a mean position, anyone, about its fixed point. I will call that one as a fixed point. Fixed point, or it is also called equilibrium position because it is fixed. It is called equilibrium point. Okay, equilibrium position along a straight line, along a straight line at any instant of time, at any instant of time. This is nothing but there should be along a straight line. Okay, the straight line is necessary here, where it is a linear simple harmonic motion. In this simple harmonic motion, the very important point is the restoring force. The restoring force is always directly proportional to what? The displacement of particle. The displacement of particle from, the sentence should be very important, from the mean position. Mean position. It means this restoring force is directly proportional to the displacement of the body from the mean position. Here the negative sign indicates what? Both are in opposite direction. The restoring force is towards mean position, but displacement is from the mean position. From the mean position. This is the linear simple harmonic motion. Example for this one, very simple. The mass is attached or a mass is connected to a loaded spring. Okay. Example, the motion of mass attached to a spring. It is the example for what? The linear simple harmonic motion. Here also same. It is a special type of periodic motion in which the particle moves. It is a mean position. Okay, to and fro, then repeatedly. It means its mean position is repeated again. About its mean position, this is a fixed position or equilibrium position. In between, it means in between to and fro, there is a mean position under the restoring force. If the restoring force, if the external force is removed, it is continuously oscillating like that. It means it is a restoring force, again it is a restoring force, again it is a restoring force, again it is a restoring force when the one external force is removed. Okay. The restoring force under the action of what? A restoring force whose magnitude is directly proportional to what? Displacement of the body. If this surface is a frictionless surface, there is no any restriction, there is no any resistance, air resistance, there is no any air resistance, there is no any friction here. This displacement is continuously same because this restoring force is directly proportional to what is displacement of the body. Up to where the external force is applied, that displacement is continuously same. It means this restoring force directly proportional to the displacement of the body. Okay. It is nothing but the linear simple harmonic motion. After that, then the second type is there. The second type is the angular simple harmonic motion. I'll remove this one. Second one is, the second type is here the angular simple harmonic motion. Angular simple harmonic motion means there is the displacement should be an angle. Angle means what? That is angular displacement. Okay. If one rigid support is there, if there is a rigid support, one bob is hanged with the help of a string. When you apply the force like this, when you apply just force like this, it means its weight of the body is directed towards the ground. It is always directed towards the ground, whose mass is m, and under the action of gravity is g. That is mg is the force. That is the weight of the body. When you apply a certain force like this, it displaced from its mean position, about its mean position up to here. It is called the displacement of the body. Again, it is when you apply the certain force, it is displaced up to here. From this displacement, this is called, considered as this is a two position. Okay. When that external force is completely removed, it comes back and repeats the mean position, and it displays the same displacement in the other side of its mean position. Okay. Again, here the displacement should be same here. The displacement should be same means what? It covers, it makes a certain angle at here, that is called theta. How much external force is applied, the theta is increased here. It means if the force is increases, the theta is also increased here. Okay. It means what? This is nothing but the perpendicular distance. If you apply the force like this, the perpendicular distance is obtained here. It means what? There is a production of a torque. Torque is nothing but what? The rotating effect. The rotatory effect is here. When you apply the force like this, its displacement is perpendicular to that. Displacement is nothing but like this. Force is applied. I will draw one diagram here. Okay, this is one body. If the body at here, if the force is applied like this is called the external force. Okay, the body starts to vibrate, or the body starts to oscillate along the circular path like this. Like this, it is moving like this. Okay, it means what? It is nothing but a displacement of the body. This is displacement of the body is correct. Okay, but this displacement should be, it's along here. The perpendicular line or the length of the string is always same here. Here also force, here also force, here also force is there. This length or radius of the circle is perpendicular to the force. Here also the length is there, it is perpendicular to this one. It means what? This is the production of torque. Okay, if it is a torque, when it takes a new position at here, there is the mg is a force always directed towards the ground. Then its components are there. There are two components here. If it is theta angle, here also what? The theta is an angle here. What here? One is the along the direction here. It means up to here is the displacement of the body. It is the displacement of the body. One component of the mg is here, and another component is at along the string. Along the string is there. If it is the angle theta is there, this become what? Mg cos of theta. And this component it become what? Mg sin of theta. Because it is an adjacent side, cos is there, it is an opposite side, its component is here. These two are parallel to each other. Now mg sin theta. If you apply the force like this, the force is restoring force is direct towards the mean position. The restoring force is always directed towards the mean position. Restoring force is directed towards the mean position. It is the mean position here, and it is called the FRE. Because here the restoring force is nothing but what? Mg sin theta. Restoring force is nothing but mg sin theta, or it is considered as F sin theta. Then in this angular simple harmonic motion, there is a production of torque. The torque should be what? The restoring force, which is a displacement. Its displacement should be same here. That displacement considered as a S. S is a displacement. And also with some theta is there, some angle is there, that is sin theta. That should be the sine of theta. This become what? Mg sin theta. Okay, I'll write here mg sin theta. Then it become what? Mg sin theta. It means this torque is depends on the theta only. It means what? The displacement of the body here and here both always same. M is the mass of the body, it is constant. G is the acceleration due to gravity, it is also constant here. Displacement at both sides, the displacement of the body is always constant here. It means what? The torque is depends on the angle theta. In this, the mass mg, it is the force, restoring force, and the displacement of the body, both are what? Are constant. Both are constant. It means what? The displacement, the tau is a torque which is proportional to these two are constant, is proportional to what? Sine of theta. But this theta should be from the mean position, the restoring force is towards the mean position. Okay, the theta is increasing from the mean position. Okay, now if theta is very small, what happened? This torque is proportional to theta, but this theta should be minus. Why it is minus? This is minus because the restoring force F, okay, the restoring force is what? Directed towards mean position. But angular displacement, is theta. But the angular displacement of the particle, that is theta. It is from mean position. It means what? In opposite direction. The negative sign indicates here. The negative sign. About the negative sign is like this. Fr is not a free. It is Fr is a restoring force. I'll write its definition. Today's last part is its definition is simple. The motion of a particle, which oscillates to and fro about its fixed, it is not a fixed position, it is a fixed axis. It is an x-axis or the y-axis, fixed axis, or it is also called equilibrium position or equilibrium position. Okay, it is about its main position is there, its displacement is also there, and I will mention here also at any instant of time. In this situation, the torque of the particle is directly proportional to the angular displacement. Okay, the torque, or it is also called restoring torque, because restoring force is applied here. Here the restoring force is applied, mg sin theta. Okay, the restoring force, restoring torque is directly proportional to the angular displacement. Angular displacement of the particle about the mean position. It means the torque is proportional to minus of theta, or also the angular acceleration. That angular acceleration called is the alpha. This alpha is also proportional to, here the alpha is also proportional to what? Sorry, this alpha, okay, alpha is proportional to minus theta. Why it is minus theta? Torque is nothing but what? It is a restoring force into the displacement of the body. It is nothing but what? Alpha is an angular acceleration. The relation between, in the 7th chapter, system particles and rotational motion, the tau is becomes what? The I into alpha, where I is the moment of inertia. Okay, I'll explain in the next classes here. Okay, this is the restoring force and angular displacement of the linear simple harmonic motion and angular simple harmonic motion in this form. That restoring force is equal to what? mg sin theta. Okay, here very important thing is that mg sin theta. Okay, in next class we'll discuss about the next part of this one, about the simple harmonic motion, some extra part of the simple harmonic motion. Okay.